Hi, this is Nico. In today's lesson, we will practice adding, subtracting, multiplying, and dividing rational expressions. If there ever was a great lesson to practice, this one is it, because in these problems, the more you practice, the more you get right, and the more you begin to feel confident about math. The concepts we will use on today's lesson include factoring, and in working with the rules of fractions that you learned and loved so long ago.
I love working with fractions, Dave.
I know, my little mathematical genius. So today we will be practicing 4 problems, and we will be multiplying, dividing, adding, and subtracting rational expressions. The thing that I want to mention here is a rational expression is one of those things we used to be afraid of, but we aren't anymore. Dum, dum, dum. Fractions. So we are going to be working with fractions, and we have to remember some of those simple rules. The rules for simplifying rational expressions are the same as the rules for working with fractions. So if I were to have 3 over 4 times 2 over 6, I could multiply the numerators and the denominators and then simplify. Or I could start to simplify in the problem and work it out that way. Remember with division, in division, if you had an expression, it was a rational fraction or a rational number divided by another rational number, we know that we could change that division to a multiplication and flip, or we would multiply by the reciprocal of the second term. So that would be 3 over 6 times 12 over 2. We just flip the numerator and denominator to change from division to multiplication and work out the rules using multiplication. Now, this is the part that scares us, but is pretty easy, especially when we're working with rational expressions with algebraic terms. If we had 3 over 6 minus 8 over 9, we want to subtract these expressions, but we must first find the common denominator. We have to find the common denominator between 9 and 6. And we'll be doing the same thing when we add and subtract fractions or rational expressions later. Let's get this factoring party started. We must look at what can we factor, either using greatest common factor, factoring trinomials, difference of squares. We have many tools. So I'm going to look at every expression and factor. Top expression, I can factor out a 10, and that's x minus 4. The denominator of the first expression is a very simple trinomial factoring problem. Multiply to get a positive 8, add to get a negative 6, done. And now we have an x plus 3 in the numerator here, which is already in its simplest form. And we can 5x plus 15 greatest common factor, 5 times x plus 3. All right, now we're almost at the last step. Now what I'm going to do is I know that I can start canceling. I can only cancel once if the same term is in the numerator and the denominator. But I want to do something important here. And before I start canceling, I want to look at all of the terms that would make this denominator 0. Because, of course, you know that 0 in the denominator makes an expression undefined. So I'm going to just come over here and I'm going to give you the short, simple answer, and then we'll look at why. But we have x minus 4 equals 0, so x cannot be 4. X cannot be 2. and x cannot be -3. I'm just going to put that x cannot equal, and then just these little terms over here right there. And now what I'm going to do is I'm going to cancel x minus 4, x minus 4. There's an x plus 3. I can cancel that with an x plus 3. And I end up with a 10. Oh, look at this 10 and this 5. Can I reduce that 5 and just put that as a 2? I sure can, because these are all now attached by multiplication. And if I can cancel or reduce any of the numbers or the binomials, I can cancel and simplify. Now, multiplying and dividing are basically the same process, except for in division, you have to multiply by the reciprocal. So when it's a long problem like this, number 2 up here, and I see it in the book as a division, I just write it down as a multiplication and make sure I use the reciprocal of the second term. So as you can see in number 2 with the division problem, as I copy down this long problem in the book, rather than writing out the division, I'm just going to go ahead with the first step and multiply by the reciprocal. So in this situation, my x squared minus 1 moves to the denominator, and I get an x squared minus 7x plus 6. And you can see right from the beginning, these are all pretty easy factoring problems. So you don't want to take too long to figure out how to factor these. In fact, I'm just going to write them all out real quick for you. Numerator of the first expression. Denominator of the first expression. Numerator of the second expression. Denominator of the second expression. Now I'm ready. I've got them all in factored form, and I'm ready to cancel. X cannot be 6. X cannot be any of these numbers. Cancel, cancel. Here we are with number 3, our simple addition problem, addition and subtraction, common denominator. Common denominator. What are we going to have to do to this expression to see if we can start getting a common denominator? Factor. So let's just come on over here. I'm going to factor everything and then see if we can get a common denominator. The first expression is already in simplified form. And now let's see if we can factor the numerator and factor the denominator. Very nice. So, common denominator, we have an x plus 3 binomial term over here and 2 of them over here. Obviously, we need another one over here, so we're going to have to multiply. Remember, whenever you multiply anything with the denominator to get them the same, I'm just going to put parentheses just to make them look even more similar, but the same anyway. We have to do the same to the numerator. So I am multiplying this first expression by 1, or x plus 3 over x plus 3. And now The first thing I'm going to do when I do addition and subtraction problems is I'm going to draw one big line, and I'm going to write my denominator because that's not going to change. It's already factored and it's already a common denominator. So I'm just going to come down here and finish that off. What I really need to do once I found the common denominator is start to distribute and simplify the numerator. This is where you don't want to make big mistakes. Here we go. See this x plus 3? We're going to multiply it times x. So I'm going to kind of distribute, which is fine. I'm doing it backwards, but I wanted to write it over in this column. X times x is x squared, and x times 3 is 3x. And now I'm going to distribute this too, just for fun. It's pretty good. Can I combine like terms? I sure can. And that will get us x squared plus 3x plus 2x plus 5x plus 6 all over x plus 3 times x plus 3. Can I now factor this expression to see if it will cancel, simplify with any of those x plus 3 expressions? X squared plus 5x plus 6 is x plus 3 times x plus 2, and that's all over x plus 3 times x plus 3. And now I can cancel and simplify. That gives us x plus 2 over x plus 3. X cannot be negative 3. Now you can leave it without parentheses. But just remember, if you do, don't try to cancel those x's. They are attached by addition. Here's a fun one. This is the subtraction of a rational expression, and the denominators similar but not the same. So we're going to have to figure out how to find a common denominator between both of these expressions. So what I'm going to do is I'm going to come over here, and I know that 2x plus 5 does not resemble 5x minus 2 in any way, and the only way that I'm going to get a common denominator is by multiplying my second expression by the denominator of the first and multiplying the first by the denominator of the second. So let me just do that for you. Remember, if I multiply by the denominator to keep the integrity of the problem, we have to multiply the numerator by the same expression. And I'll come over here. We're just setting up the problem now. And there we have it. Now, rather than worrying too much about the denominator, I'm just going to rewrite the denominator in factored form. I'm going to put a long line, and I know that later on I might have to work with the denominator, but for right now it is 5x minus 2 times 2x plus 5 for my denominator. Now in the numerator it's going to get a little tricky, and we're going to just have to be really careful, which is why practice is an incredible ally. Here we are. We have FOILing for the first. We're going to distribute all of the necessary terms, and I'm just going to write that first expression out. 5x times 3x. This is the first numerator expression FOILed. And now I'm going to move on to the second, which is a negative 2 distributed with this binomial. And we have negative 2 times a negative 2x is a minus 4x minus 10. Okay, so now we have this long numerator expression, and I would like to combine like terms to simplify it and see if we can factor it. 15x squared, negative 10x, negative 6x, negative 4x, that's a minus 20x, plus 4 minus 10 is minus 6, and that is all over 5x minus 2 times 2x plus 5. Now, can we factor? First of all, I've got this large coefficient in front of the x squared, and I know that's going to be a very difficult factoring problem if I can't find a greatest common factor. Can I find a greatest common factor between these numbers, the 15, 20, and the 6? I really can't, because 15 and 6 can be divided by 3, but 20 can't. And at this point, I'm going to start asking myself questions. I'm not going to say, oh, I can't factor it. I'm going to say, is there a possible way to factor this problem? If I can't find it fairly quickly, I'm just going to say, well, at this point, I can't factor it, so I cannot factor anything and I cannot cancel. So I'm going to leave the answer just like this. There's no way that I'm going to try to factor that right now or try to cancel it with any of those factors. Now, the only thing is, in fact, this is an acceptable answer for us. However, I need to find my restrictions on the denominator. And that is the one final step where I'm going to say what would make either of these factors in the denominator 0, because that's what x cannot be. So I'm going to, because this will give us a little strange restriction on the denominator, I'm going to write it out, and I'm going to say 5x minus 2 cannot equal 0, and 2x plus 5 cannot equal 0, or I'm going to set each factor to 0. And all I'm going to do here is add 2. 5x equals 2, and x cannot equal 2 over 5, 2/5. X cannot be 2/5. And the same thing with this one. I'm setting this factor to 0, to x cannot equal negative 5, and x cannot be negative 5 over 2. If this were a rational function, there would be something strange going on at x equals 2/5 and negative 5/2. Something strange would be going on, and I'm thinking we would get some vertical asymptotes. That's the lesson in the classroom.
Thanks for your help, Nico.
Anytime, Dave.
And thank you for watching.